Hey folks, welcome to your video lesson on properties in the order of operations unit. I can identify properties from mathematical expressions, and I can use properties to solve problems. So keep in mind that properties does not always mean the same thing as you would think it is. Don't think property as your house, think property in math now. So let's look at what does it mean. Okay, so what does it mean or look like to have equivalent expressions? What does that sound like to you? If you think of the word equivalent, you might think equal, and we remember expressions or number sentences. So I could have 4 plus 3 is the same as 3 plus 4. They both equal 7. That's an example. But remember, of course, if you're wondering anything, stop and think, write down questions, write down some things, other examples that you think it could mean as well. What is a property? In terms of math, of course, okay? So I don't want to hear people say, property is something that you own. Well, not quite in math, okay? A property is going to be a rule, so I'm not writing it down, but you could write it down, is a rule that's going to be true for all these sets of real numbers. The vocabulary you're going to come across here are properties. There's a commutative property, associative, distributive, identity property, and there's two different kinds. And then there's also equivalent expressions, what we just talked about. So make sure you understand those vocabulary words, and as you come to an understanding, you could write down those in your notes. So let's first look at the first property here, distributive property. Notice this is a key concept, so this might be a great thing to write down. Have examples. In words, distributive property means to multiply the sum of a number, you multiply each addend of the sum by the number outside the parentheses. And of course, it makes more sense for a visual for most of us. So some examples here. In number forms, we see that 3 times the sum of 4 and 6 is the same as doing 3 times 4 plus 3 times 6. And vice versa, we see that 5 times 7 plus 5 times 3 could be written as 5 times the sum of those numbers. And in algebra, you'll often see it like this, where those letters just represent that those could be any sort of number. So you can write it in either way. So what we want you to do here is use a distributive property to rewrite each expression. Okay, so we want to write an equivalent expression, then we're going to evaluate. So you need both steps. So for this one, I notice I'm distributing. Distributing is kind of like handout, if that helps you remember. I distribute papers, I hand them out. So I distribute 6 to 3, so that's 6 times 3. Notice the plus comes down, and I'm also distributing 6 to 4. So that's me writing an equivalent expression. Me evaluating is me solving. So 6 times 3 is 18, plus 24. So I get a value of 42. Next one, I can rewrite an equivalent expression. So notice my 2 is my common number on the outside, and that is with the 2 and the 5 on the inside, so 2 plus 5. So 2 times the sum of 2 and 5. To evaluate that again, if I went from this way, I could get 4 plus 10 and get 14. Notice that's the same as if I do it this way. 2 times 7 equals 14. Notice they're equivalent expressions. You end up with the same answer either way you solve it. Some of you might be wondering then why you would use this. Sometimes it's going to come in handy definitely when there's algebra and there's letters that we don't know. So think about how that could happen. So an equivalent expression to this would be 9 times 5 plus 9 times 1. Evaluating that expression would be 45 plus 9 for any value of 54. So these are equivalent expressions using the distributive property. Those are all addition questions. There could be subtraction as well. So if I had 7, 2 minus 7 times 1, that's the same as 7 and 2 minus 1. So make sure that your sign in the number stays the same as well. So how can using the distributive property help you become more efficient and more confident in your problem solving? So for example, how would it come in handy for a problem like this? So when I'm looking at Tour de France, the Tour de France is a cycling race through France that lasts 22 days. If a cyclist averages 90 miles per day, about how far does he travel? How does this help me? So the distributive property could help me. So it's looking 22 times 90. Maybe I'm not allowed to use a calculator and I don't like long division. I can break it up and rewrite it by breaking this up as, well, this could be 20 plus 2. And that is all times 90. So that's one way to think of it. And again, you have different ways because you are stopping and thinking. So come to class ready with what you want as well. And so that's one way that I could think of using the distributive property to help me. By then I'm just using my tens place and my values that I know to help me put that together. And there are other ways as well. Bring those with you. So again, the vocabulary, we're talking about properties here. Here is another key concept. Here are the other properties. You might want to write down this chart. So you have the title, what it means in words, and some examples in algebra form of what they are. Okay, and we'll go through each of these in detail, but I would pause here and write down an example. Write down this chart. So commutative is the order in which two numbers are added or multiplied, does not change their product or sum. Notice this only applies to addition and multiplication. Associative property is that when three numbers are grouped, the order they're in, added or multiplied, you should get the same thing. So again, is just for addition and multiplication. An identity property, that's going to affect 0 and 1. So when I add 0 to any number, the identity does not change. When I multiply by 1, the identity does not change. So that's just a quick rundown of those ones. We will go into them in more detail. So properties with examples. So again, commutative, I like to do this as I see the word commute in there. Commute is when you drive. When I drive from home to school, I drive the same distance. So if I'm driving home to school, and that's 5 miles, that should be the same as me driving school to home, and vice versa. So what it means is, say 1 plus 4 is the same as 4 plus 1. It doesn't matter which direction I'm driving. If I'm driving from one place to the next and they're the same, it should stay equal. Okay? So I like to just have commutative as commute, mean they can move and it doesn't change the value. Associative, I like to think of associate, who you associate with. Who you associate with is who you group with. Okay? Associative property is a lot like middle school here. So for example, if 1 and 2 are friends today, they're leaving 3 out. But it's middle school, so the next day, suddenly, 1's left out and 2 is besties with 3. It doesn't really matter because in the end, they are all the same. If you work it out, they both still equal 6. They're the still same 3 friends. The order in which I group them in multiplication and addition does not matter. So make sure you have these examples from this page and or the other page. Identity property of 1. So again, identity is not going to change. Meaning if I have the identity of 4, if I multiply 1 by 4, I still have 4. 5 times 1, I still have 5. So you notice your identity is not changing when you apply multiplying by 1. Identity of 0, meaning again, if I add 0, my identity will not change. So if I use a variable, a will always be a. X will always be x if I add 0 to it. 13 plus 0, hey, what do you know? It's still 13. So the identity of the number you start with does not change. So now you try, watch the directions, and try to do what it's asking based on your properties that you have in your notes. So you're being asked to name the properties for each of the equivalent expressions. So this one, I notice that I have 1, 2, 3 is equal to 3, 1, 2. I notice that the order changed. Nothing was grouped, so this one is commutative of addition. The order changed. On this one, I noticed that my 4 was distributed to each of my addends. So this was distributed. It was distributed to each number. And again, you should be pausing and checking on your own. I noticed that 5 times 0 equals 0. Well, that wasn't one of the properties. This must have been a mistake. That would be a property of 0. So any number times 0 would be 0. So that's actually a little extra one for you, property of 0. Woohoo! If that said, however, 5 plus 0 equals 5, then that would be the identity of 0. Over here, I noticed that 12 and 3 equals 3 and 12. I noticed the order just changed, so they made a commute to work. Commutative. Here I noticed that the groupings changed. The order did not, so that would be the associative. And since it was addition, associative of addition. And one more here, we have a multiplication. 16 was multiplied by 1 and stayed at 16. So that would be the identity property of 1. Okay, so a little bit more here. So mental math, looking for the sums and products that end in 0. They're easy to compute mentally. So computing mentally, this is where the commutative property helps us because we can rearrange things in multiplication because the order doesn't matter based on the commutative property. So notice here, if I was being asked to do 4 times 12 times 25, I can rearrange the order using the commutative property because 4 and 25 are easy to compute mentally, and then multiplying by 100 is also fairly easy. So then I grouped it on that one to make the associative property. So you're using properties more often than you know because you haven't had names for them before. So on these ones, try these and then justify your step. And you might do them a little differently than someone else, and that's okay. So on this one, I could work it out. Instead, I'm thinking, what would be easier for me? Maybe it's easier for me. Again, you might do it differently than I might do 40 times 5 first, but I'm not sure because that'll give me a number. Oops. Like 200. I'm not sure that's going to be easy, but it might be. I'm going to try that. I'm going to do 40 times 5 and then times 7. So what I did is I just rearranged them. So I use my commutative property. Then I'm going to group them because I want to do these ones first. So I'm doing my associative property. And I get 200 times 7. Now I just know 2 and 7. This is kind of like breaking this up as a 100 on the outside. So I know that's 14 and then those 2 zeros there. So again, that's my way of showing it. Yours might be totally different, and that's awesome. For this one, 89 plus 15 plus 1, these are grouped. I'm going to use the associative property to group different ones. And I'm going to group 89 and 1 together. So I'm kind of using commutative and associative at the same time, since I also rearranged the order. Then I see that that's 90 plus 15, which is a lot easier for me to add together. Okay? So I use both commutative and associative in each of those. Last one, I would have these in your notes. Have examples in your notes. These are using algebra. You can change them using numbers as well. Notice they break them up by the property of addition, multiplication for both of those. Identity property of addition or of 0, and a multiplication or of 1. And then the 0 property, when you multiply a number by 0, you get 0. Have those in your notes and be ready to use them. That would be a great thing to put on a study guide as well. So, rewatch what you need to. Check out examples in the book, personal tutors, online textbook, Khan Academy. So many resources for you to be successful. You just have to make the choice.